As usual, we start with a quiz. The first problem is one that everybody should get, and everybody did get. The other two maybe are a little bit curveballs based on the assignment that was due today, okay? Not sure that you learned everything in that assignment, so these aren't going to count as far as grading, but I did want to see what you do with it, okay? So the first one is the quantity 4x to the seventh, y to the third, multiplied by the quantity 3x to the fourth, y squared, z to the fourth. We can remove the parentheses, so I'm just going to do this step by step. I'm going to write it out again, 4x to the seventh, y cubed, parenthesis, 3x to the fourth, y squared, z to the fourth. It's a multiplication, so I can just write this without the parentheses. When I get to the 3, now so I'm going to write 4x to the seventh y cubed, then I got to multiply by 3. Well, I put parentheses around that 3 to indicate that it's a multiplication. If I just write a 3 there, you might confuse it with an exponent or something else. If I put dots in there, it breaks it up. I could have put a dot in, but I didn't. And then the x to the fourth, y squared, z squared. And it's not z squared, it's z to the fourth. Keep an eye on me. Okay. Now, that's just a bunch of things multiplied together. So I can multiply the 4 by the 3. So I'm going to bring the 3 over here. So now I've got 4 parentheses 3. And that takes care of the 4 and the 3. Then I have x to the seventh times x to the fourth. And I put that in parentheses. Parentheses around x to the seventh dot x to the fourth. And then y to the third times y squared, y to the third dot y squared, z to the fourth. I think it's not a bad idea for you to write out every step on a problem like this, even though you know what to do. Everybody did know what to do, okay? You want to be sure you understand how everything goes back to the rules. The rule is, so far, we've got a bunch of things that are multiplied together, and we can group them any way we want to, okay? We can rearrange the order. If I multiply 3 times 5 times 7, it's the same as if I multiply 7 times 3 times 5. It's the same three numbers. I get the same product. It doesn't matter, and everybody knows that. But here's how we use it with the symbols. Well, then, 4 times 3 gives us 12. Now, x to the seventh times x to the fourth gives us x to the 7 plus 4. We're going to talk a little bit about why that is, but right now everybody knows that rule. And I think everybody applied it. And then y to the third times y to the second is y to the 3 plus 2. And then z to the fourth. There are no other z terms, so it's just z to the fourth. And we can't multiply x's by y's or z's by x's or y's by z's, okay? Because all these are variables. We don't know what their values are. And if they have one variable now, they could have, or if they have one value now, they'd have different values later. So there's no way to multiply them together to simplify this expression. So we simply do the additions. 12x to the 11th, that's 7 plus 4 is 11. Y to the 3 plus 2 gives us y to the 5th. And z to the 4th is just plain z to the 4th. There it is. If we wanted to check it, we could let x equal 2, let y equal 3, let z equal negative 2. Evaluate this, evaluate this. That's a pretty good check. If we let everything equal 1, that's not a good check because when you raise 1 to the power, you just always get 1. And 0 is not a good number. But that's one way to check it. Okay, now let's make sure we understand why. Why does x to the 7th times x to the 4th equal x to the 7 plus 4? Well, because if I write out x to the 7th, right there is x to the seventh, right? I wrote 7x's, dots in between them, put parentheses around them. Now multiply that by x to the fourth, that's x times x times x times x. And if I apply the usual rule, I can remove these parentheses. I don't need parentheses around the 7x's or around the 4x's. I can just write out all the x's together. And how many am I going to write out? I'm going to write out 7 for the first parentheses, and then I'm just going to continue and write the 4 for the second parentheses. And then I can count them, and if I counted correctly, if I did it right, I've got 1, 2, 3, 4, 5, 6, 7. Those all came from the x to the seventh. And 1, 2, 3, 4 all came from the x to the fourth. And that equals x to the 11th, which is, of course, x to the 7 plus 4, because we got 7 of them and we got 4 of them. Okay? You want to remember that because it's real easy to confuse this rule with the rule you're going to use on the third problem. Okay? Where you're going to have to multiply the exponents, and you want to understand why you multiply the exponents. Otherwise, it's much easier to make a mistake, which costs you time, aggravation, worry, paranoia, all kinds of things, okay? You don't want that to happen. It can cause you to miss points on a test also. So let's look at the other two. Oh, it's still a little bit wet. How did that happen? Yeah, it'll dry off. Okay. Second problem, I've got 6x to the fourth, y to the sixth, divided by 2x to the seventh, y to the second. Well, that equals, okay, we can divide any factor of the numerator into any factor of the denominator, any factor of the denominator into any factor of the numerator, okay? So we can divide the 2 into the 6. That gives us 6 over 2. We can divide x to the seventh into x to the fourth. Giving us x to the fourth over x to the seventh. And we can divide y to the sixth by y to the second. So I can write my expression as 6 over 2 times x to the fourth over x to the seventh times y to the sixth over y to the second. Now, without using rules, I'm going to show you how this works out, and then I'm going to show you how you do it using the rules, okay? We don't need any fancy rules. We can divide 6 by 2. Let's just take care of that. That's 3. Now, x to the fourth divided by x to the seventh. Well, I'm going to write the thing out. Probably should have left myself more room, but x to the fourth, there are 4 x's. That's my numerator. My denominator of x to the fourth over x to the seventh, I've got 7 x's. So I can write my x to the fourth over x to the seventh by expanding it out and showing all the x's. And my y to the sixth over y to the second, I can do the same thing. Y to the sixth is y times y times y times y times y divided by y times y. Okay, now you've probably seen people tell you you can cross these things out, you can cancel. Okay, I hate cancel. What I really hate is it's taught without emphasizing the rules under which it's done, okay? It's dividing factors of the denominator into equal factors of the numerator. Okay? And people don't remember that, and they cancel things that don't need to be canceled. And 90% of people come into a pre-calculus class do incorrect cancellation, okay? Without understanding. So we want to understand it. Okay, so I can write x times x times x times x over x times, all the x's. I can separate out x times x times x times x in the numerator and x times x times x times x in the denominator. So far I've written 3 times the quantity x times x times x times x divided by x times x times x times x. Now, if I multiply that by 1 over x times x times x, then I could multiply these fractions back. X times x times x times x over x times x times x times x multiplied by 1 over x times x times x. How do you multiply fractions? You multiply the numerators. If I multiply the numerators, x times x times x times x times 1, I get x times x times x times x, which is a numerator I had in the last step. If I multiply the denominator with a string of 4 x's and a string of 3 x's, I'm going to have a string of 7 x's. So by the rules for multiplying fractions, I can do this. I can do similarly with the y's. Running out of room here. I've got 6 y's in the numerator, 2 y's in the denominator. Now I take 2 of the y's in the numerator and 2 of the y's in the denominator, gives me y times y over y times y. That leaves me 4 y's in the numerator, and I'll need a 1 in the denominator. So I can see that if I multiply these fractions, 2 y's in the numerator multiplied by 4 instances of y in the numerator gives me 6 of them, right? And the y times y in the denominator times 1 gives me y times y. So you should see that I still have exactly the same expressions that I started with, step by step by step. Now, why did I do that? It's because I've got 3 multiplied by x times x times x times x over x times x times x times x. Numerator is the same as the denominator, that's 1. And I still have 1 over x times x times x. With the y's, I've got y times y over y times y, which is just 1. And then y times y times y times y over 1, which I can just write as y times y times y times y. I don't need a denominator there anymore. And now I've got 3 times 1 times 1 over x times x times x times 1 times y times y times y times y. The ones that I've got, other than the 1 in my numerator, the one that's multiplied by 3 and the one between the 1 over x times x times x and the y times y times y times y, those are just ones, and they can be eliminated because multiplying 3 times 1 is just 3. And if you wish, multiplying 1 over x times x times x times 1 is just still 1 over x times x times x. And then that's multiplied by y times y times y times y. Now maybe I should have left the 1 under that so I can see that I multiply this fraction by this fraction. In other words, I multiply the 1 over x times x times x by the y times y times y times y over 1. when I multiply the numerators, I get 3 times y times y times y times y over x times x times x, which equals 3y to the 4th over x cubed. Now that's as basic and fundamental as you can be, and you would do well to practice writing it out like that so you understand it. You'll understand it more deeply. If you want to just memorize the formulas, as long as you get them right, no penalty, I'm fine with it. But I'm finer with it if I know that you understand why the rules are what they are. Okay? Now I'm going to do it again, and I'm going to shortcut a few things. I do want you to think about avoiding shortcuts until you do it. Now, if this was instead of x to the 4th, it was x to the 98th, you wouldn't write out 98x. But you could imagine, right? And if you have an x to the 56th in the denominator, you could imagine 56 of them. So you group 56 of these with 56 of these, and you're left with 41, 42, what were my numbers, 98, 57, 42 x's. You can still think it, but you'd be crazy to write it out. And everybody here looks perfectly sane, at least today. Okay. Now, we have, let's do it again. We have 6x to the 4th, y to the 6th, divided by 2x to the 7th, y squared. And we could write that again as 6 over 2 times x to the 4th over x to the 7th times y to the 6th over y to the 2nd. 6 divided by 2 is 3. X to the 4th divided by x to the 7th is x to the 4 minus 7. Now that one you might not be familiar with, but you are now. Whatever's in the denominator, the exponent of x in the denominator is subtracted from the exponent in the numerator. Okay? And y to the 6th over y to the 2nd is y to the 6th minus 2. You'll see this in the open math assignment. It'll be well explained. We'll have videos, have all kinds of resources to reinforce this. But make a note of it right now. Okay? Just like on the first problem, we had x to the 7th times x to the 4th. That was x to the 7 plus 4. And we could have written it that way. Okay, and we did write it that way. There goes my support. Okay, x to the 7 times x to the 4th is x to the 7 plus 4. Many of you wrote it out that way. You know that rule. Okay, and I'm comfortable that everybody's okay with that one. So all you got to do is add a rule here. The rule is if the exponent, if you have some power of a variable in the numerator and the same power in the denominator with different exponents, you subtract the exponent in the denominator from the exponent in the numerator. Okay? We can even write that out. I'll write it out kind of small here. X to the a divided by x to the b is x to the a minus b. That's, yeah. Textbook, whatever resources you happen to be using might use different letters. That's the rule. And you understand that. I don't think you have any trouble with that. Okay, so we have 3x to the 4 minus 7. Well, 4 minus 7 is negative 3. And we have y to the 6 minus 2. That's y to the 4th. Okay? This is a perfectly valid solution. You have a negative exponent here. I'm going to say more about negative exponents. But you have a negative exponent. All right? That's fine. We'll understand negative exponents a little better in about 10 minutes. All right. If you follow these rules and get a negative exponent, great. There's another thing you can do though. We could write this 3x to the negative 3y to the fourth. This might be an unnecessary step, but I'll write it this way. I'm going to put the x to the negative 3 out on the end. So 3x to the negative 3y to the fourth becomes 3y to the fourth x to the negative 3. Again, I'm just changing the order of multiplications. And now I'll see explicitly what x to the negative 3 is. X to the negative 3 is 1 divided by x to the 3. There are many, many reasons for this. And we'll see a compelling reason in just a few minutes, okay? But there's the rule. So that a to the negative b equals 1 over a to the b. So there are two new rules of exponents that I don't think you had to use in the assignment that's due today. Okay? And everybody did that assignment, did real well. Okay, if you didn't do it, get into the late assignments page and do it. Okay? Although, everybody knew what they were supposed to know today, so that's the bottom line. Okay? Everybody did okay. You're going to have negative exponents and stuff, and that's the assignment. Okay? Okay, then we have 3y to the fourth times 1 over x to the 3. We could write that just to be real specific about it. 3y to the fourth over 1 multiplied by x to the third over 1. And my parentheses there kind of slipped in front of my exponent 4. So it looked like the whole 3y over 1 was for the fourth parts. 3y to the fourth, parentheses, x cubed over 1, parentheses. And I wrote that wrong, 1 over x cubed. I distracted myself when I noticed that y to the fourth in the wrong place. Probably would have written it wrong anyway, but okay. Make sense? This is just what we had in the last step, except the 3y to the fourth is expressed as a fraction, so we can clearly see the numerators that multiply and the denominators that multiply, and that gives us 3y to the fourth over x cubed. Now, that looks a whole lot like what we got over here when we wrote out all those x's and y's. But you see how handy this rule can be if you have big exponents, you can't write everything out like this. I wouldn't even write an x to the seventh or a y to the sixth out. Yeah. But you should understand it. You should be able to visualize writing out all the doggone x's. X to the 7,598. Everybody can visualize 7,598 x's, right? Are you missing one? Well, get with it. No. You can't visualize that very well. I'm fairly good at visualizing things up to 10,000, but I can't visualize. Yeah, I always miss one. Once in a while, I can't get it right. Okay, but I can write the exponent and use these rules, okay? And you pretty much have to with a lot of problems. All right? Okay, two new rules, and there's one more that you're going to need for the last problem. Now, I probably need a little more board space. So we'll get that. Okay, the third quiz problem was the quantity 3x squared y cubed z to the fifth raised to the third power. So let's write it up. 3x squared y cubed z to the fifth raised to the third power equals what? Well, I'm going to write out a lot of detail first. Then we'll shorten it with some rules, okay? I'm going to write out, give myself a little more room here. I'm going to write out 3x squared y cubed z to the fifth multiplied by 3x squared y cubed z to the fifth multiplied by 3x squared y cubed z to the fifth. That's because if I cube a quantity, I've got to write it out 3 times with a multiplication between each pair. Okay? And now that I've done this, I can see that, okay, well, I just write 3 times 3 times 3. That wasn't hard. Okay? Each one has a 3 in it, so I'm just changing the order. And then I'm going to write my x's. And of course, they're all the same, x squared times x squared times x squared. And then my y's, well, y's cubed. So I got y cubed times y cubed times y cubed. And z to the fifth is going to give me z to the fifth times z to the fifth times z to the fifth. Well, 3 times 3 is 9. You multiply that by 3. And gee, I think I'm off the screen here. Right? There we are. I think everybody can understand what I wrote out. So again, I've just written the original expression that's cubed, but I've written out 3 copies of it, all in a line. I've rearranged the order of multiplication, so all my plain numbers are in one set of parentheses, all my x's in another, all my y's in another, all my z's in another. Everything is exactly what I had at the beginning. 3 times 3 times 3 is 27, because 3 times 3 is 9, and 3 times 9 is 27. Then x squared times x squared times x squared. Well, x squared times x squared is x to the 2 plus 2, right? And you multiply that by another x squared. Well, I'm going to just say it's x to the 2 plus 2 plus 2. It's just an extension of the rule that everybody seems to have used correctly on the first problem. Okay? Everybody okay with that? Nothing mysterious? And then y cubed times y cubed times y cubed is y to the 3 plus 3 plus 3. And z to the fifth times z to the fifth times z to the fifth is z to the 5 plus 5 plus 5. That's very easy to write down a multiplication when you need to write down an addition. So you want to check yourself. You want to think back to what everything really means. All these z's and all the x's and everything were written out. But that gives us 27x to the 6th, y to the 9th, z to the 15th. Everybody okay with that? Seem pretty obvious? It does until you start confusing multiplications with additions. It's really easy to do that. Okay. The other way to do it write out the original expression again. 3x squared y cubed z to the 5th, the whole quantity raised to the 3rd power. We can see what happens from what we did before. If we write out 3 copies of what's in parentheses, we're going to get 3 3s, and they're multiplied together. That tells us that we have 3 cubed. And what are we going to have? We're going to have 3x squared. Okay? Multiplied together, x squared times x squared times x squared. And that's just then x squared cubed. Similarly, where we had y cubed times y cubed times y cubed, we can simply write, so that's going to be y cubed cubed. We just have to be careful. And again, if you write this, imagine what happens. You really ought to write out the details a few times so that you lock them in. But again, as long as you use the rules correctly, it's okay. Make your own judgment. All right, what's 3 cubed? 27. Now, x squared cubed means x to the 2 times 3. Why is it x to the 2 times 3? Well, here's x squared cubed. X squared times x squared times x squared. That's what x squared cubed is. And we see that that's going to be x to the 2 plus 2 plus 2. But 2 plus 2 plus 2 is 2 times 3. Okay? And actually, I'm going to change the order of that. It doesn't matter. For cubing x squared, we multiply 3 by the exponent. Fair enough? So here's another rule. A raised to the b to the c power is a to the b times c. Now we could use that rule here. Y to the third is y to the 3 times 3. So that's y to the 3 times 3. Is that consistent? Well, over here on the first run through the problem, we had y cubed times y cubed times y cubed, and that's y to the 3 plus 3 plus 3. That's 3 times 3. Similarly, we're going to have z to the 3 times 5. Now, we get our final result. 27, x to the 6th, y to the 9th, c to the 15th, and we see that it works out perfectly. Totally agrees with our first solution where we wrote out every possible expression. Okay, so we know that we're safe using these rules as best we can know anything. Okay, yeah, we got to stay a little skeptical. All right, so we have 3 rules. Now, I've written them down in different places. I'll use A's and B's here. A to the B times A to the C is A to the B plus C. Now I use the X's and Y's and stuff before, but I'll write it out with consistent letters. And A to the negative B is 1 divided by A to the B. Those are the only rules you need to deal with exponents. Fair enough? Learn to use it. Get an assignment. And you can always go back to the assignment and practice. Okay? Always use an assignment for practice later. All right. Let me give you one to work. Now, you could write this out in all the detail, but right now, let's try to use these three rules and see how it works out. And there are little pitfalls there, things I haven't shown you. So if you run into trouble, I'll come around and get you out of trouble as best I can. Okay, now I'm not going to write out all the details on this one. A couple people did, and they did it correctly. Okay. So it's good that you know all the details, and you want to write out several of your homework problems showing all those details. That's my advice. But then you also want to be able to use the rules. So I'm going to just do this using the rules. Okay, so I've got 2x to the sixth y cubed to the fourth divided by, oh, no, I'm a step ahead of myself, divided by x squared y to the fifth, that whole fractional expression to the fourth power. I could write that next as 2x to the sixth y cubed to the fourth divided by the quantity x squared y to the fifth, the fourth. Then I can write the 2x to the sixth y cubed to the fourth as 2 to the fourth times x to the sixth to the fourth times y cubed to the fourth over the x squared y to the fifth to the fourth would be x squared to the fourth, y to the fifth to the fourth. That goes in the denominator. Now, at least one person went off to the side and wrote out 4 different expressions and did that very neatly in a very systematic fashion. That was really good. Okay? So please, I encourage you to do that. You then can check your work, if you wish, by writing it out using the rules for exponents. Okay? Since you're seeing the rules and you're applying them and you understand them, that's excellent. So if we use this, 2 raised to the fourth power is 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. Then x to the sixth to the fourth is x to the sixth times 4. And y cubed to the fourth is y to the 3 times 4. So my numerator becomes 2 to the fourth, 16, x to the 6 times x to the 6 to the fourth is x to the 6 times 4, and y cubed to the fourth is y to the 3 times. Here's my numerator. My denominator is x squared to the fourth, y to the fifth to the fourth, which is going to be x to the 2 times 4, y to the 5 times 4. And now it's just a matter of doing the multiplications. My x to the 6 times 4, well, 6 times 4 is 24. Y to the 3 times 4 is y to the 12th. So my numerator becomes 16, x to the 24th, y to the 12th. The denominator has x to the 2 times 4, which is x to the 8th, multiplied by y to the 5 times 4, which is y to the 20th. And now we can write this as we have the 16. We have x to the 24th divided by x to the 8th. That's x to the 24 minus 8. And y to the 12th divided by y to the 20th. is y to the 12 minus 20. I started to write that in fractional form, but I'm just repositioning a couple of things on the board. Okay. And then 24 minus 8 is 16, so it's 16 x to the 16th. And 12 minus 20 is negative 8. So one valid solution is 16 x to the 16th, y to the negative 8. Now, when you do the homework, sometimes you're going to be asked to express these without denominators, sometimes without negative exponents. And I'm watching the clock wrong. We're 4 minutes over, but we're done here in just a second. So that could also be written as 16 x to the 16th divided by y to the 8th. I think everybody has a really good handle on this. Okay, practice it so that you maintain that really good handle. Okay. Okay, nice job.